Suppose that a manufacturer of widgets has a total cost per month given by the formula C equals 13x plus 8,000, where the 13 is the variable cost, $13 per item, and 8,000 is the fixed cost that they have to pay no matter what. And let's say that there's a revenue function given by 50 minus 0.01x times x. Can we find the profit function? So to do this, all we need is the formula P profit equals revenue minus expenses. So I'm going to subtract the two formulas. Notice that the revenue can be rewritten as 50x minus 0.01x. If you distribute the x, you'll get x squared there. And the cost is simply 13x plus 8,000. We just want to subtract them. So we'll get negative 0.01x squared plus 37x minus 8,000. Okay, so we have a quadratic trinomial. Now we want to determine when will the manufacturer have a loss, a profit, or perhaps break even. And several production levels are given. Here's where they make no items at all. Here they make 2,000 items, and then here 4,000 items. Let's see what would happen if they made no items at all. We would let the input of our function be a 0. And we would want to plug in that 0 everywhere where we see an x in the formula. Okay. If they don't make any items, then they end up with a negative $8,000 profit. And it's negative, meaning they didn't make money, they lost it. So that's a loss. Whenever the profit is less than 0, that's a loss. Now let's try to find the profit if they make 2,000 items. All right, now they have a gain of positive $26,000. Let's see if they make 4,000 units, what'll happen. Will they have a profit or a loss? Oops, 4,000 plus 37 times 4,000. All right, now they have a negative 20,000. And again, that is a loss. So how can that be that they have a loss and then a gain and then a loss? It's because the function is a quadratic, which will be a parabola shape. And we can see that on the next page. Here's a picture of the revenue function, R of x. And here's the cost function, C of x. As the number of items produced goes up, the cost function keeps growing. So they're having to pay more and more to make the items. But when it comes to the revenue that they make, it looks like if they make too many items, the revenue will actually go down. They won't be able to sell that many items. And so there's an ideal number of items here to make in order to maximize their profit. And if we subtract the two functions, we can see that the profit makes an upside down parabola shape. And if we want the maximum profit, then we want them to make the right number of units to achieve that maximum profit. It happens somewhere around 2,000 units.